can allow ourselves to discharge the system because it does no harm. We can discharge the system at the early stage of the fire and extinguish it when it is still very small. With Inergen, we have really a three-dimensional extinguishing effect. So the extinguishing efficiency is available throughout the enclosure, ceiling to floor. The specific weight of Inergen is close to that of atmospheric air. So in case of small leakages, like small minor leakages around doors or whatever, does not have a significant effect of Inergen. If you use heavier gases like the chemicals, they have much more difficulty to maintain the extinguishing effect over time. And according to the standard, the extinguishing concentration shall be present for minimum 10 minutes. Imagine a door that is not entirely closed with a chemical agent. The heavy gas will pour out of the room and fresh air will come into the room. With Inergen, that process is very slow, and we can show that at our full-scale demonstrations, and I hope you are all sometime going to participate in a full-scale demonstration with Inergen. And a full-scale demonstration with Inergen in our world, that's a demonstration where you are standing inside the room where the gas is used, so you can see for yourself, you can feel how it works on your own body, that it is not harmful. You maintain conscious, you are not experiencing any difficulties. Tens of thousands of people have tried it across the globe. So it is very efficient, it is very reliable, and there are no consequential damages from the extinguishing agent. Everything that can endure the air that we breathe, any material which can be exposed to air, can also be exposed to Inergen, and even more materials than tolerable to air, because we have no oxygen in the Inergen. So Inergen is very safe and there is no damage. I have to make one point here, and that is hard disk drives. They are sensitive to noise. So in case you know any systems with an inert gas and the nozzles do not have nozzle silencers, you should do something about it, because we have the means to reduce the noise from the system, from our system, from the Inergen system, to a level where it is not damaging hard disk drives. Next slide, please. So this is a kind of a summary. We have no damage to any equipment. It is safe for people. It is so safe for people that we can even do full-scale test. And this is, I want to mention this here. This is for a lot of users very important, not the least the oil and gas companies, who are very keen on user employee training. So, and we are working in certain markets where this is one of the key drivers for Inergen, is that you can take all your personnel which is working in this area, you can put them in a full-scale test. They will be able to experience how the system really works. So you can make drills that will prepare these people to act much safer and better and more rational, because they know the system and they know what to expect and they don't panic. So this is an important thing. It's a sustainable solution. There is no harm to the environment. We borrow the components for Inergen from the air, and when we one fine day use it, we just let it back into the environment. No change. We don't manipulate anything. We just borrow the resources of nature for this specific purpose, to secure that we can extinguish fire very efficiently. We can minimize the loss of revenue due to fire, and I would say that there's no way that Inergen will make damages other than the damages that the fire made up to the point where we extinguished it. It's a very efficient and safe solution. Next slide, please.
Sir, I have one question.
Yes.
Sir, the inert gas system, the pressure will be, it's a high pressure system. It's around 200 to 300 bar. After the selector valve, it is getting suppressed to 60 bar. So if that 60 bar, while it releasing through the nozzle, the pressure will be reduced, maximum it will be reduced, or that 60 bar will be released, sir. Because you told we can stand inside also. So that 60 bar, if attacked on us, then it will not create any issue, or to that room, the wall and all.
No. Yes, we have. It's true that we can calculate. We can design a system with different kind of downstream pressures in the pipework, and I would say typically the pressure is 50 or 60 bars. At the nozzle, a little bit less, but not that much. But as soon as the gas leaves the nozzle, the pressure will be converted to turbulence. If you have a pressure nozzle without the nozzle silencer, there will be quite a lot of turbulence and noise from the nozzle. When you have a nozzle silencer, you will reduce the speed of the gas leaving the nozzle, but just outside the nozzle, the pressure is the room pressure. So there will not be like any kind of pressure effect on the room, except the pressure that we calculate from the overpressure vent. So we calculate, for example, 500 Pascal, 200 Pascal for a very light construction maybe. And then the pressure relief valve will secure that there is not a build-up of pressure in the room, and the pressure will not exceed the calculated 200 Pascal, for example. So apart from that, yes, we have a high pressure system with 300 bar, 200 bar system, and in the cylinders, the pressure is that throughout, it goes through the manifold. We have orifices in different places. There are also a possibility to make a constant flow regulator, but we use very often, we use natural flow with orifices. And the flow from the nozzle is also calculated by an orifice. But after leaving the nozzle, there will be no pressure around it. There will be turbulence. There will be gas velocity. Does that answer your question?
Yes, sir. Thank you.
Thank you. Here we have a number of applications, and I think you will have the presentation afterwards, so you can go through. I will not go through every one, but of course, data centers, server rooms, technical rooms, they are a very big application for Inergen, but also offshore, midstream, and upstream. So rigs, platforms, and refineries, midstream, petrochemical is a big area for Inergen, but there are many more, like cold storage, warehouses, food logistics, museums, hot production, and lots of others. Next slide, please. In general, we can say that the systems are capable of doing more or less the same thing. There are some exceptions, and that is if you have applications where there is a high heat capacity or the risk of thermal runaway. Could be both lithium-ion batteries, but it could also be conventional batteries. It could be high-tension gear where you have the risk of light arcs and so on. There, Inergen is by far the preferred agent, because if you use any chemical, not only FM-200, if you use any chemical and you have the risk of a thermal runaway or light arc or heated material or deep-seated fire to a high degree, then the chemicals, they will produce an extreme amount of toxic and corrosive decomposition products. With Inergen, there will be absolutely no residue after an activation, except from what the fire produced itself. Inergen will reduce the amount of carbon monoxide that the fire produced, opposite to the chemical agents where the carbon monoxide concentration after the extinguishing with a chemical will go up 10 to 20 to 50 times because of the extinguishing mechanism of the chemical. Inergen will dilute the carbon monoxide that was already produced by the fire. With Inergen, there is no toxic or corrosive things like hydrogen fluoride that can attack materials. So with Inergen, just vent the room. Of course, if there has been a fire with a suit, it may need to be cleaned, but it is not because of Inergen. It is necessary to install an overpressure valve, an overpressure damper with Inergen, but also with FM-200. Inergen cylinders can be placed a long distance away from the protected room. So yes, we have more cylinders, but we can put them in a basement, in a room which is not critical for the operation, 50 meters away, 100 meters away, 3 stories up, 3 stories down. So with Inergen, we have practically no or very few restrictions for where we can do it. We can put the cylinders outside in a container or a shelter. We can tolerate work outside temperatures exceeding 50 degrees with Inergen. Under 20%, minus 20 degrees can also, it's not relevant in many Middle East countries, but anyway, the temperature span, the working temperature for Inergen is very wide, and our system is even wider compared to others. With our system, we are making a very large and complicated zone installation. So we use one cylinder bank and we pipe out to many different protected sites. We have systems installed where it is 200 to 300 meter traveling through pipework, and it's working just fine. We are using quite small cross-section pipes compared to the chemical-based systems that need to discharge in 10 seconds. We have no issues with liquid and two-phase flow gas, so that when the liquid inside the pipe is evaporating and create a two-phase flow, that it's very difficult to predict what is coming out of the nozzles. Therefore, we have much more flexibility in the installation with Inergen. When we do a zone installation, it's very easy because we have one standard size cylinders. So whenever there is a usage of the system, it is just shifted one-to-one with the standard size cylinders. We do not have a special fill for each individual cylinder to accommodate the different zones. So therefore, again, super flexible system, super easy for to keep spare cylinders in a country or at a vendor that can serve any system in whatever configuration. Inergen cylinders, they need to be not replaced, but recertified every 10 years, like all other pressure vessels, transportable pressure vessels, not pressure, it's cylinders, not vessels. Vessels have to be hydro-tested more often, but Inergen cylinders every 10 years. We can also use ultrasonic testing. And it is very simple to do a service on the Inergen system, and we even have a lot of tools securing that the function and the reliability of the system can be tested at the installed system, not just in the factory where we do all the testing, but also testing of each critical component without losing the gas from the system. That we have from Fire Academy, but that's I think that's a seminar of 1 or 2 hours in itself. I will just mention. Next slide, please. Well, I think this is a question which you should already now be able to answer, but I think it's very much for the customer, the end user, to letting out PFAS into the world, it may not be so good for our reputation. So this has to be analyzed by the end user, the client who's going to install this. There should also be like an analysis. It could be that an Inergen system is really not practical to use. There are many applications where Inergen would not be the best choice, where a water sprinkler system, for example, is the right choice. And there are also applications where foam is much better. Inergen is absolutely useless as a local application system. So every system has its place, and of course it needs to be analyzed in a proper way to make a risk analysis to find out what is the risk and how do we best address it without applying other risk or unknown risk or effects on the environment or possible effects on people who may be exposed to it. But if I should answer this question, I would say that Inergen is by far the safest and most sustainable and most efficient of any clean agent choices. Next slide, please. Yeah, again, this is about the impacts of the system, the risk analysis, of course, elements like how vulnerable is the organization to the downtime, the services, what would be the cost of cleaning, restoring. Can we get the equipment to re-establish our facility, and how long time will it take? A lot of specific tailor-made industrial machines and processes, they take a long time to replace, and that will advocate the use of a very efficient fire extinguishing system. Next slide, please. So a little bit about PFAS, because there's a lot of talk about PFAS. And here we have a molecule. This molecule shows the black balls, they are carbon. The green ones, they are fluorine, and the red one is oxygen. But anything which contains elements in its molecule where you have a carbon atom connected with 2 or 3 fluorine atoms, that is a PFAS. So in this little picture, you can see there's 1, 2, 3, 4, 5 elements which are defined as PFAS. Next slide, please. And FM-200 is classified as a PFAS. It contains F2 and F3, C2 and CF2 and CF3. We have seen that major PFAS manufacturers have stopped their production of PFAS, mainly except China, where you can get your access to both Novec and FM-200. This calls also for a separate seminar of 1 to 2 hours to go through that. But the case is that there will be restrictions in the future. There are many international organizations, they are beginning to phase out the use of PFAS in the fire extinguishing systems because they know it will give them a bad reputation, and they have also now, they're beginning to understand that it is not as safe and green and environmentally friendly as the suppliers once told them. We see in Europe that there will be restrictions already now. There is a ban considered. And all in all, you can say that availability of PFAS, it varies by country. We don't know the position of the United States yet, but we surely know that in the United States that there are a lot of litigations going on against the manufacturers of PFAS and a lot of mitigations going on against the system integrators where they use PFAS. That would be Novec and FM-200. One big, very reputable company in the United States has gone into Chapter 11 to protect against the litigations because they have been distributing PFAS. So it's a serious issue, and I would say those who do not make a plan how to get rid of PFAS and discontinue the use of PFAS, they can face serious consequences. Next slide, please. So here's a direct comparison. It's let's say a recap of most of what I have said, that for FM-200, the major issue it is when you have had a fire and used FM-200 and Novec, there is a lot of toxic and corrosive decomposition that will be dissolved in the moisture in air and create concentrated acids that will cause corrosion. If people are exposed to them, it is very harmful, lethal to incapacitating. Inergen has absolutely no issues. We can do the full-scale test even with fire. Of course, the fire should be not threatening to the life of the people. So we do it, of course, in a sensible and responsible way. So about the global warming potential, FM-200 is about 3,000, and this is one of the concerns, but the other concern nowadays is also that it is a PFAS. And I would say on PFAS that there is no such thing as a safe and good PFAS, because just even if the actual substance produced, one PFAS substance was found to have no issues at all, the production of it has serious consequences. And we see a lot of big problems in areas where PFAS production has been going on. It is real problems. It is people suffering from much higher cholesterol, cancer, immune defect syndromes, and a lot of very serious issues. The societal cost of PFAS pollution is already very high, and it's increasing by the day. So the sooner PFAS is ended, the better. Next slide, please.
Sir, in FM-200, it says like in the manned area, it can be flowed and it cannot be flowed. Both the answers are there. Could you explain that, sir? That logic?
Yes. In the standard, it is addressing, for example, the NFPA, it is addressing the effect of the undecomposed, of the natural gas itself. It is only evaluated by one factor, and that is the effect on the heart rhythm. There is no central nervous systems evaluation of the chemicals and so on. So it is by the standard, the NFPA 2000, it is said that you can use it in a normally manned area as you can with Inergen. But you should not make full-scale testing with the FM-200. It is also mentioned in the standard, in the FM-200, in the NFPA 2001 standard, it is mentioned that you should not make full-scale tests with FM-200, which is not mentioned with Inergen, of course. So therefore, there is a big difference. And again, we need to make a seminar of maybe 2 hours just for that, but because the way the standard has been defined requires some insight to understand the full consequences of how you can use the standard. But it is correct that it is said that you can use it in a manned enclosure. That is all the clean agents listed, they can be used in a normally manned enclosure. So, but do not do, for example, a full-scale test. And it is also mentioned in the standard that due to the effect of the fire, there may be life-threatening situations due to the breakdown and so on. So that is mentioned, but it is allowed to use it in a manned area. That's absolutely correct. I'm just giving you the more deep understanding on what we are actually dealing with. But if you just go by the standard and say this is it, then you can say, okay, then the thing that you can draw from the standard is that yes, Inergen, there's no problem, you can use it for the full scale, but with the chemicals you cannot use them for the full scale because then you expose people to the gas, and that should not be done.
Thank you.
Hydrofluoric acid, it will be certainly conductive. It is listed as a clean agent. It has a low footprint. They use you use less cylinders with FM-200 than you do with Inergen, and you generally have a fast and effective suppression, except where you have lithium-ion batteries, other applications with the risk of thermal runaway in any form, or high amounts of heated material. Then you cannot use any chemical, any synthetic fire extinguishing chemical, fluorinated chemical. It is not so easy to make complex installation with complex zone systems. The cost of the lifetime of the system is high because there will be restrictions, so you cannot utilize the full length of the system, the technical length of the system. It will be obsolete before you have used the system for 5 decades, for example, 50 years. You cannot use it so long time. It's a PFAS. There is a phase out and restrictions. There are in certain areas taxes. It is requiring a two-way pressure relief, and the cylinders, they must be placed rather close to or within the protected enclosure, whereby you use the space that you should use for other operations. With Inergen, yes, we use more space, but it can be moved to an inexpensive storage location in a basement or a utility room or somewhere. It does not need to be in or near your server room. So next slide. With Inergen, yes, we have certainly a first-class quality extinguishing system. It can be tested in any way. It can be verified for operation and reliability throughout the installed lifetime. We can do the personnel training, the full-scale testing. If we do complex installations in areas where it is not well specified by the standard, then we can do an installation and verify by a full-scale test of the actual system being installed. It can be used to phase out FM-200 in practically all situations, and it can be used in other applications than FM-200 serves. It is completely future-proof, and it's sustainable. So organizations doing a sustainability accounting, they can use this actively and score points on choosing an Inergen system instead of a FM-200, a PFAS-based system. We have partners all over the world. We can support systems, and we have systems installed from in the very north of Svalbard, in any other hemisphere, and down to the South Pole, where critical scientific stations are protected by Inergen. The next slide, which I think is the final. Yeah, that's my email. So if any of you have something you want to address specifically, a very good question, something you have always wondered, I would be happy to help you and try to answer any questions you have. So if there is a need to have a Q&A session, let's do that. Otherwise, I have heard that there is going to be a little quiz or something. I would like to participate. There's money on stake, I hear.
There are some questions asked by the participants in the group. Can you see the questions? There are 2 questions asked in the group, the chat.
I have them here. I can present them.
Please.
Yeah, Torbjorn, question 1. As you said, Inergen gas discharge can be witnessed inside room. If so, how safe to someone who's witnessed if Inergen oxygen level reduced to 12% and normal breathing needs 21% oxygen level?
That's a good question. 12% oxygen is not enough under normal circumstances. There you will have the symptoms of so-called hypoxia, which is too little oxygen for the brain. But Inergen is special by the composition. Inergen is reducing the amount of oxygen to, for example, 12%, but we are adding at the same time carbon dioxide to the mixture and to the air which is inside the room. So to understand the effect of carbon dioxide, I typically say that people should sit on the chair and start to hyperventilate. Then if you do that, all of you, I will also be sure that there are no more questions after 1 or 2 minutes, because you will all become unconscious. So what is happening to you when you are hyperventilating, when you're breathing too much, is that you are washing out carbon dioxide from your lungs, from your blood and your lungs. When the amount of carbon dioxide in your bloodstream is going down, then the brain is closing down the small blood vessels, and therefore there is not enough blood and oxygen coming through the brain. So even if we breathe a lot, that can make us unconscious because we lose carbon dioxide. We are adding carbon dioxide as it is in a slightly higher concentration, is having the opposite effect than when we were hyperventilating. It is opening the small blood vessels a little bit so that we are having more blood flooding through the brain. It's happening every day. It's a completely normal function. Every night we sleep, it closes down, and we get up out of bed, it's opening. So Inergen is just manipulating the body to think that it has been working, and therefore the brain needs more oxygen. So when you are breathing 12% oxygen with 3.5% carbon dioxide, you have 10% more oxygen available to the brain than if you were breathing 21% oxygen. So you will actually get a better blood and oxygen supply to the brain when you are in a 12% oxygen concentration. And therefore we can do the full-scale testing, because people will have plenty of oxygen available to the brain. This is a topic of a 1 hour or 2 hour seminar in its own. I hope you understood a little bit of my answer. And I saw that there was several other questions, but I did not manage to take notice of them. So if someone will...
Yeah, I have it here, Torbjorn. What kind of material to be used for piping if more pressure to be used?
Yeah, we are using typically black steel, sometimes galvanized black steel, but there is also the option to use stainless steel for some applications. The piping used in the Middle East is typically for the downstream pipe work is Schedule 80. And so it's like, yes, it has to be a certain quality, a certain grade of pipe, but that is something that we are engineering. The system is calculating the pressure in the downstream pipe work, and you can decide and you can define and you can engineer your pressure. It has to be over a certain limit according to the UL and FM rules and NFPA, but it is not a complex thing. So it is depending a little bit on the geography where we are, what kind of a specific pipework standard that we are using. But in some systems also Schedule 160. But typically Schedule 80.
Okay.
In the downstream.
Sir, excuse me, sir. Can I ask one question, sir?
Yes.
Sir, we are mentioning in our specification in Schedule 80, but contractor is providing the Schedule 40. But we are asking to contractor, he said, no, we can manage the pressure. It's not a big issue. But we have already mentioned in the specification, its impact on the pressure or something, Schedule 40.
Yeah. Yes, if you're using Schedule 40, that can be done. You will, because that's a little bit also depending on what dimension of pipe work that you are using, because Schedule 40 is a general standard, and the pressure, the maximum working pressure is depending on the actual cross section of the Schedule 40 pipe you're using. But you can, in the IMT, you can make an engineering where you will be able to use the Schedule 40. It will result in slightly, you may need to go up one size of pipe when you're using Schedule 40. And in some systems, depending a little bit on the system, you may not be able to achieve the goals. For example, the discharge time. If you then you have to use Schedule 80, but it is something that is calculated in the IMT calculation software, so it may be quite correct. Yet, yes, here we can use the Schedule 40, but I'm just mentioning that typically there will be used Schedule 80 in we're using in Denmark in our installations. We're typically using 60-65 bars working pressure of the pipe work. We're using DIN kind of DIN pipe standard. So it's like, yeah, it's different, but so it's a matter of calculation. Did that answer your question?
So nowadays a NOAC system is using in the IDF room and telephone room, GSM room. NOAC system is a.
Sorry, I was not. I could not hear that.
I think he's muted.
Please unmute your mic. Yeah, it was muted.
I thought it was a question. Yeah.
NOAC system is using in the market nowadays. All are providing the specialist NOAC system for the IDF room and telephone room, GSM room.
Yeah.
So how's the gas? This okay? I mean,
Novec.
Hazard. Yeah.
Novec is a PFAS. It's in many ways similar to FM-200. I would say the main difference is that the amount of decomposition is higher with Novec than it is with FM-200.
So is comfortable for this gas system in the. It's okay, and we can consider for this one NOAC system.
For Novec, if you're asking about Novec system, Novec is the trademark of 3M, and 3M have stopped the production of Novec. So Novec in chemically is called FK5112, and I would say that let us make a seminar on more detail about that because it's a little bit complicated. but Novec is certainly a PFAS. It is discontinued by 3M. So 3M is no longer supplying, manufacturing and supplying. You can get FK5112 from Chinese manufacturers, but I wish to mention that the purity and the quality of the gas from the Chinese manufacturers, according to my information from 3M, is really, really risky. It's containing contamination, which is seriously toxic.
Okay, thank you very much, sir. Thank you.
Then there is a question, Torbjorn, if you know why in FM-200 system there is a need of a two-way pressure relief valve.
Yes, simply because when you discharge a liquefied gas, and that is actually the case for all liquefied gases, then there will be a pressure flux due to the evaporization of the liquid gas, so that the pressure will first increase in a steep, sharp rise, and then due to the evaporization and the cooling of the gas during the evaporization, then the pressure will drop down sharply and do a under pressure. And then and this is happening within a few seconds. So the pressure will go up and down and up and down and up and down for about 4, 5, 6 seconds in a lot of sequences. So there will be like a oscillating effect of plus minus pressures, which is, by the way, the worst thing for a building structure. It's very good for demolition of walls and buildings, but it's not very good for a building you want to keep. So therefore, it is necessary to have the overpressure vent as also an underpressure vent. So it has to be a two-way valve that can both let pressure into the room and out of the room. So it has to do with the evaporization and continuous cooling and pressurizing of the room during the discharge.
Then there is a question if you can explain a little bit about the room integrity test.
Yes. The room integrity test is a very important tool where you use a fan and a pressure sensing device to measure the leakages of the room. And then you will use the result, the ability to pressurize a certain room. There has to be a software that is compatible with the fan device that you are using. So you can calculate the estimated hold time of the extinguishing system. And that is quite interesting, because when you're doing a door fan test in a room and calculate and there's a small leakage, you calculate with Inergen, then it's easy to hold the 10 minutes holding time for the extinguishing concentration. But for the heavier gases, when you have small leakages from the room, it is not that easy. So when the door fan test is made, it is very often making it difficult with the chemical, the fluorinated chemical gases like FM-200 and Novec, because they are heavy. So the door fan testing is highly recommended, and in some jurisdiction is specified that there must be a door fan test to support the design of the system and the verification of the compatibility of the enclosure where the extinguishing system is used and the design of the extinguishing system. We have with Inergen, in case you have a situation where you have a room which is quite leaky and it is difficult to maintain the extinguishing concentration. We have and that's one of the flexibility beauties of Inergen. We can do what we call our continuous system, where we have an extended discharge, so we have more cylinders that compensate for the leak, but we can do it in a way with our system that we will never get in a dangerous situation of too low oxygen. we can always maintain so that in case of a system with a large amount of extended discharge, we can keep the extinguishing concentration, for example, for 30 minutes, but it will never go under 10 or 11% or 10.5 or 12 or whatever we design. It will always be minimum 10% and maybe maximum 10.1 or something like that. It's a very, very simple and very smart engineered system. Hope that covered your question.
Then there is a question, if there is a false ceiling in a room, I mean 2 enclosure, so that is in that case, what should be the arrangement of nozzle, and same as the control of the system? Should it be a common control or separate?
Normally, when you have a false ceiling or a elevated floor or something like that, you will put nozzles inside the false ceiling and the elevated floor. And that is for a number of purposes. Of course, if there is combustible material inside the cavity of the room, then that should be covered by nozzles. But the next thing is, for example, a false ceiling. It is typically a very light structure. And if you just have, and maybe you have no combustible material over the false ceiling. So, but when you then have a discharge in the room underneath, and you do not have nozzles inside the false ceiling, then there will be a risk that the false ceiling will be lifted and the ceiling plates can fall down. So therefore, we always recommend to have the nozzles in the false ceiling. Of course, if the false ceiling is just 5 centimeters or something, it can be difficult to put it, but then the risk of lifting is not high. So yes, we design it with nozzles, the same kind of nozzle distribution as in the room. And then the gas distribution is calculated by the IMT. So you have whatever cylinders for the room, you have one pipework, and you distribute out to the room, to the ceiling, and to the floor. You can do that from one downstream pipework to each separate part of the enclosure. And with our IMT, the energy management tool, the calculation and the distribution of gas is very accurate. So you will get equal concentrations in all compartments.
Is that a hand somebody has?
Like, we cancel. So,
Your voice is not clear. It's
the
breaking.
other volume.
The connection is very bad
Yeah,
at my
your
end.
voice is not clear.
Can you maybe make a written question in the chat, and then Nicholas can do it?
Then we can take the next one here, and that is maybe a webinar on its own, but maybe you can shortly describe what agent is better than lithium batteries.
What for lithium-ion batteries?
Yeah.
Well, I think you would all know what I would say now, wouldn't you? But I can quote from different actual experience by independent test organization, SINTEF in Norway, SINTEF RISE. They have been conducting a test with different kind. They have a sprinkler, they have water mist of different kind, they have particulate aerosol, and they had Inergen. And it's a couple of years old, and they concluded that they could not believe their own eyes, because Inergen was the one that provided the highest degree of cooling and controlled the situation totally. And this was completely surprising, because Inergen is not cooling. It's a gas, so only water is cooling. So therefore, they could not explain the results of the first test, and concluded that further testing is and research is needed. I think it was a very easy thing to explain, because if you have a lithium-ion battery, About 10% of the energy stored in the battery is electrical. 90% is combustible electrolyte and polymeric plastic materials. So when a lithium-ion battery burns, it is like a petrol fire, because the electrolytes inside the small plastic bags, it is highly combustible, and it has 10 times more energy, the combustible material, than the electricity stored inside the battery. So that's the reason why Inergen is so efficient, because it controls the combustible liquid fire beautifully. Of course, it cannot remove the electrical energy. It has to dissipate by itself. In those cases, we use Inergen with our continuous system, so we provide an extinguishing concentration as long as needed. And that is typically until the fire brigade can arrive, they can safely enter the room, and they can start to cool down whatever has got a thermal runaway. They can cool it down with water. But Inergen will be essential to secure that the fire is stopped. Right now, RISE Fire Research, they are in the middle of new testing, and I cannot give you a lot of detail. I'm involved in the project, but I can tell you that the results were completely identical with the test 4 years ago. That Inergen was able to control the lithium-ion battery cabinet fire so it would not spread from one cabinet to the next. That was not doable with any of the other systems tested, which was all of the systems available in the market. They did not test FM-200 or Novec because that cannot be used for that application. 3M have directly sent out instruction to all their distributors that please do not use Novec for lithium-ion battery fires or fires where there's the risk of a thermal runaway, because it will not extinguish the fire. It will, on the contrary, it will add to a massive production of hydrofluoric acid, of carbonyl fluoride, isofluorobutene, and a lot of other seriously toxic and corrosive substances. So 3M have instructed all their suppliers, do not sell this to lithium-ion battery or other thermal runaway things. Inergen can control it. The unfortunate thing right now is that there is not like a specific standard for it. There's not a standard for the design and layout of lithium-ion battery storage systems. But the best practice, as I could say, is that within, I think, half a year from now, we will have let's say the midway results of the RISE Center research, where we can draw out the conclusions that a Inergen system will continue. Actually, it can designed in that way. It can do the job.
Perfect.
Was
Then
that?
Yeah, I believe so, yes. Then there's 2 questions left, but because of the time, Torbjorn, we will make I have the copy of the answers, questions,
Okay.
and then we can
Yeah.
make the answer on, we have the email, and we will make a post, so we will answer the last 2 questions because we need to have the quiz.
Perfect, Niklas.
As you all can hear, there's a lot to talk about. We could spend many hours, so as Torbjorn also mentioned, if you would like another session with some topic, please reach out so we can arrange that in the near future. We would love to do that, because as Torbjorn also started to say, that we are more than just a selling company. We would like to have the discussion with you. So please reach out if you want more sessions with different topics. We would love to hold them. Right, Torbjorn?
Yeah. And I will not participate in the quiz. I'm too tired of talking.
Yeah, it's a bit detailed webinar, but it's really good anyway. Okay, so we will have a 10 multiple choice questions now, and you will be given 1 minute to answer all the questions. So I will share my QR code now. So please write your full name clearly in the form, the Google form, so we can identify the winner. And once you submit your answer within a minute, so the winner will be announced on our TIECONN LinkedIn page. So stay tuned. Now I will share my screen. You can start answering the questions. So here is your question. Thank you and good luck. Please scan this one. You will get the questions.
I think is time is over.
Yeah.
Okay. So on behalf of yes, on behalf of TIECONN teams, I extended my heartfelt thanks to everyone who joined us today. Insightful webinar on effective fire protection system, FM-200 was Inergen. My special thanks to uh, our distinguished speaker for sharing their in-depth expertise, real-world insight, and practical comparison between FM-200 and Inergen systems. Your presentations sparked valuable discussion and deepen our understanding of the clean agents fire suppression system technology. Once again, and thanks to all the participants who spent the valuable time to this wonderful webinar. And stay tuned our upcoming sessions and to continue supporting our mission to empowering engineer and through the continuous learning and innovation. Thanks for all. Thanks to once again everyone.
Thank you all. Thank you,
Thank you,
Mr.
sir. Thank you
Laursen.
so much,
Thank you
sir.
to the firefighter group. Yeah.
Thank you.
Thank you, sir. Yeah.
Thank you so much,
Have
sir.
a nice day.
Thank
Good
you.
night. Yeah.
Bye bye.